Okay, so we are doing question 5C of exercise 14H, which is asking us to find all the values of x between negative pi and pi, for which cos of x equals negative a half. Now, where it says negative pi and pi is going to be really important here, because what it is it's restricting our domain. So we could write this as negative pi to pi. That's what the domain that we're working within. We're going to come back to this later, but let's now just treat it as a normal problem and we'll come back to the domain later. So we have cos of x equals negative a half. So when we come to our unit circle, because we're dealing with cos, we know that we're just looking at our x-axis, and we're asking ourselves, where on the x-axis am I going to have negative a half? So we know that's going to exist right here. That will be a half, and I could draw it up here, so it's going to be here, and it's going to be here. Next, I'll write in the coordinates of both of these. So my coordinate here is going to be, oops, let me try that again. It will be negative a half, the square root of 3 on 2. And then here, it will be negative a half, negative the square root of 3 on 2. Again, for my coordinate, it consists of both an x and a y, both x and a y, but I only care about the x because I'm dealing with cos. So there and there. So next thing I'm going to do is I'm going to draw in my lines. So I'll come here and I'm drawing in my line from here to here. And then my next line will be from here to here. Now, many of us, so let me stop here. Everyone should be able to do this. Now, many of us are going to be tempted to go, all right, well, from here to here, I've memorized my unit circle, and I know that this value is going to be 2 pi on 3. And then the other value will be from here to here, which will be, well, I've memorized my unit circle. I know it's going to be 4 pi on 3. 4 pi on 3. But this isn't actually how you would answer this question. If you were to tell me that x was 2 pi over 3 and 4 pi over 3, you'd be wrong, because we've changed where our domain exists. So what we're being told is that it exists between negative pi and pi. Well, we know that this is 0 radians. And then as I go along, this is pi. So my domain is restricted that I can't go past pi. I can't have a number bigger than pi. That would be breaking my domain. So I can't have 4 pi over 3 because it's going past pi. So that's wrong. Let me in fact rub out both of these. So how can we think about our domain? And how can we think about it in a way that maybe is a bit easier? Well, I could break up this domain into 2 parts. I could say it's negative pi to 0, and then it's 0 to pi. So as you can see, this and this is the same. Negative pi to pi is the same as going negative pi to 0 to pi. And these are the areas that I'm working within. So for the first one, 0 to pi, that would correspond to this region here, 0 to pi. So are there any values that I have from 0 to pi? And in fact, there is. I could go, well, that would be from here to here. So from here to here, we've already told me what that is. That's 2 pi on 3. So 2 pi on 3 exists there. Now, what is 0 to negative pi? Well, 0 to negative pi will be from here to here. It's like I'm going backwards, and if I go backwards, I'm going 0 to negative pi. So that corresponds to that region. And as you can see here, I have a value that exists there, this line right here. So this angle from there to there will be the angle of interest. And hopefully you can see just symmetrically, this is going to be 2 pi over 3. So here will be negative 2 pi over 3. And these will be my two angles that exist between negative pi and satisfy this. So my final answer is going to be x is going to equal negative 2 pi on 3 and 2 pi on 3. So restricting the domain can be a bit of a complicated thing for some of us. So I've kind of explained it in a bit of a different way here, breaking up my domain into two parts. If this is helpful, let me know, and if you're having any trouble, please come talk to me. Hopefully this was helpful.